I now invite Shri A.S. Kiran Kumar, Chairman ISRO, Chairman Space Commission, Secretary Department of Space, Government of India, to deliver the Sardar Panikkar Memorial Lecture for the 55th Foundation Day of the Regional Institute of Education, Mysuru.
Good morning to all of you. Chairperson of the day, Shri Kuntiaji, Shri Kant, Principal RIE, Shri Professor Senapati, Director NCERT, and all the students, teachers who have gathered here today on the occasion of the Foundation Day of this center. It's indeed a matter of great privilege to be in this Regional Institute of Education, Mysore, on the august occasion of the Foundation Day of the esteemed Institute to deliver Sardar Panikkar Memorial Lecture. Professor Kavalam Madhava Panikkar was an Indian novelist, journalist, historian, administrator, and diplomat. He was born in Travancore, then a princely state in the British Empire, and was educated in Madras and University of Oxford. Professor Panikkar held various positions in India and abroad. Prior to Indian independence, he was professor at Aligarh Muslim University and professor at Calcutta. Later he went on to Patiala state as foreign minister and then Diwan to Maharaja of Bikaner. In 1947, when India achieved freedom, Professor Panikkar represented the country at the UN General Assembly session. In 1950, he was appointed as the India's ambassador to China, and after successful tenure there, he went as envoy to Egypt. He was also Indian ambassador to France and member of Rajya Sabha. He also had the honor of being the chairman of State Recognition Commission set up in 1953. He also served as the Vice Chancellor of University of Jammu and Kashmir and University of Mysore. Professor Panikkar's contribution towards the establishment of Regional College of Education in Mysore is the standing monument of his dedication to the cause of education. As you all know, education is the most crucial foundation of any nation, leading to transformation in social and cultural lives of society. I pay my tributes to the man of this eminent personality. As part of the NCERT program, the Regional Institute of Education in Mysore, established in 1963, caters to the educational needs of all southern states of India. During the last 5 decades, this institute in Mysore has rendered invaluable service to the nation in general and southern states in particular, evolving itself as a unique organization with its increasing range of activities influencing the school education and teacher preparation in the country. I thank the Regional Institute of Education and particularly the principal, Professor Y. Shrikant, for giving me an opportunity to be here amongst you and talk to you about the Indian space program and also how the space program has tried to bring in certain facilities and tools for education. All of you are quite familiar that way back in 1957, Russia put its first object into space called Sputnik. At that time, the Americans and Russians were competing with each other to demonstrate who has more power and who is more militarily strong. At that point of time, we had in our country people like Homi Bhabha and Dr. Vikram Sarabhai, who were looking at how a new technology, a technology of space technology can be used for bringing in the benefits of this technology to the country, to hasten the development in this country. Arthur Clarke had already told that if you are able to put a satellite in a particular orbit called geostationary orbit, you can make use of that particular location for doing effective communication. You can imagine that as Earth rotates about its own axis once in 24 hours, if you are able to put a satellite in space which takes exactly 24 hours to go around the Earth, because of the relative velocity becoming zero, the satellite will look as though it is stationary above Earth. And all of you are quite familiar, when you want to look at large areas, you try to go to higher places. You climb on top of a tree or a tower or a mountain top, you can have visibility to a large area. So when you go to a place at 36,000 kilometers, 1/3 of the globe becomes visible to that, and you can do line of sight communication. So Dr. Vikram Sarabhai was looking at how this new space technology can be used for hastening the development in our country. They came up with an idea, borrowing a satellite developed by Americans, an advanced technology satellite. It was moved over India for 1 year, and in the year of 1975, in about 2,400 remote villages in our country, making use of this satellite, and like what you see today, direct to home television, direct to community television service was established, and at a time when only the 4 metros had the privilege of looking at satellite programs, like Chennai, Delhi, Calcutta and Mumbai. Even Bangalore did not have this facility. At that time, ISRO demonstrated to the country that it is possible to reach out to very remote places by making use of this space technology. For about 1 year, in these 2,400 villages, villagers were shown the possibilities of improving the farming practices, their health, welfare, and such information was beamed through the television. And you can also easily imagine when the government became aware that it is possible to reach out to the entire country in quick time by making use of space technology, they didn't have much hesitation in approving the INSAT program and the Indian Remote Sensing Satellite Program for improving the standard of living in our country. At a time when making telephone calls to your friends and relatives would have taken an effort, just to tell you how it used to be in the late 70s and 80s, if we had to call our relatives, dear and near ones, 500 to 1,000 kilometers away, we were required to go to a place called Central Telegraph Office, do a person-to-person call booking, and wait for hours. If you are lucky, you will get through. Otherwise, you have to make that attempt another day. Starting from such time, making use of our own communication satellite, what we call 3-in-1, because 3 capabilities were built into a single satellite, INSAT series: meteorology, that is looking at clouds and then predicting cyclone locations, communication, telephone connectivity, and also broadcasting. All these 3 capabilities were built into a single satellite. That was because we could not afford 3 independent satellites and 3 independent launches. So it was for the first time in the world, a satellite of that category was being built. And even the experiment what I talked to you about, the satellite instructional television experiment, it was the world's largest socio-technological experiment conducted, and for that, Professor Eshpal, who was one of the pioneers in this area, who passed away just a few days back, who has made immense contribution to the field of education in our country. He was another pioneers who was able to conceive the way this particular communication was going to reach out to the villagers and how it can be effectively utilized. So we came in with a 3-in-1 satellite constellation. Then subsequently, the first round of satellites were built by an American company for us, because at that point of time, we did not have the capability. But from 1990 onwards, all the communication satellites we are using are built indigenously. And then over a period of time, quickly the entire country was covered with broadcasting and telecommunication. Today, for example, you are able to look at in your hands what is happening anywhere in the world almost at this instant. Through the mobiles, the connectivity is there. While the mobile connectivity comes to you through the towers, tower to tower and country to country communication happens through the satellites. Similarly, in terms of cyclone, today we have a capability to look at India and its surroundings every 15 minutes in many wavelengths, and by virtue of this, we are in a position to provide information to India Meteorology Department, telling them where the cyclone is going to strike our long coastline, at least 4 days in advance, and the location accuracy is about 20 kilometers, and time error is less than half an hour. By virtue of this, what has been possible is, in India in the earlier decades, super cyclones, our Chief Secretary would recall, whether it is in Orissa or Bihar or Bengal, in these areas when super cyclones used to come, tens of thousands of people used to lose their lives because of no information about when the cyclone is actually going to impact the coastline. But today, because of the advanced warning, disaster relief agencies are able to evacuate the people, and loss of life has reduced to single digit, and that too because some of them do not heed the advice. And today we also have a capability of almost 42 satellites operating in orbit, providing information. You can easily imagine that if you put a satellite in space, the satellite can look at Earth, any part of the globe. There are no state boundaries, there are no national boundaries. It can look at the entire globe. It can look at the globe for atmospheric parameters. It can look at the globe for changes that occur due to climate, forest cover, forest fire. There are a host of applications today which is available through these satellites. We are operating about 42 satellites today, out of which about 18 of them provide us information about the crops, crop types, and we are also able to provide, by looking at the color of the ocean, the chlorophyll where it is available, chlorophyll, and then the food for fish where it is available. From that, and also the thermal front, information is provided to the fishermen in our long coastline where they should go for fishing. And by virtue of this act alone, since 1999, this is being provided, and this alone saves to the country between 10 to 15,000 crores a year in petrol and diesel that is saved, because fishermen do not have to search for fish now, they know exactly where to go. This is one of the very important development that has happened. There is a small story to this I would like to recount. When we started our launch vehicle activity in Tumba Equatorial Rocket Launching Site, at that time there was a church in that place, and Vikram Sarabhai had to go to the church and request the priest of that church to kindly request all the fishermen in the nearby area to vacate the place for providing an opportunity to the Indian Space Research Organization to develop a capability in the country which one day will become very useful. Priest made use of his good offices. He could convince the fishermen that if you allow these people to work for the country, tomorrow the country will benefit. And true to that, from 1999 onwards, we were able to provide the fishermen specific information about where to go for fishing. Today, with our navigation satellites, a satellite, 7 satellite constellation, which provides capability to our country to look at any position through a set of receivers, an independent GPS system. Using this, we are also able to tell the fishermen when they are in the sea, using their own mobile in their local language, they are even can be alerted of any impending atmospheric vagaries, if the wind speed is going to increase very high, or state of roughness of the sea is going to increase. So this information is also possible to reach to them. We are now working with the industry to make these gadgets available at affordable cost to the fishermen. And similarly, over a period of time, making use of this satellite data, looking at where to drill bore wells for getting water, or to tell the government ahead of harvesting what is the likely yield this year of wheat, rice, sugarcane, cotton, jute, and many groundnut, many of these producers ahead of harvesting. There is a center in Delhi called Mahalanobis Crop Forecasting Center. For doing all this, we needed to build a capability within the country by making use of the young talent which came out of the colleges in the 70s, mid-70s, working, starting from scratch. The first rocket launch was done using the church building, and the first satellite, Aryabhatta, was built in Bangalore industrial sheds. And starting with such beginning, where the rocket was, many of you would have seen, rocket was carried on cycles, and satellite for a particular test was transported on a bullock cart. But today, we have built an indigenous launch vehicle capability of Polar Satellite Launch Vehicle, where for 39 consecutively successful missions we have had, not only have we been able to launch our own satellites, but we have also launched for 29 other countries, 209 satellites so far, out of which more than 130 this year itself. On February 15th of this year, when our PSLV C-37 carried 104 satellites in a single launch vehicle, it was a record of kind. And what this also showed is that even though you start late, if you keep building your capability, you can move ahead of others. There are a couple of very good examples of this which I would like to recount for you. All of you are aware that man had landed on moon, a large number of missions had gone around the moon. Probes, they had landed and then moved around the moon. But in 2008, when we launched our Chandrayaan-1, the credit for discovering the presence of water molecules on the moon and the process responsible for water molecule formation, the credit for discovering that actually goes to Chandrayaan-1. We also had in this orbiter a moon impact probe. It went and crash landed on moon, and that place where it landed is called Jawahar Sthal today. And we are working on Chandrayaan-2, where instead of crash landing onto moon, we are trying to build a system which will land on the surface of the moon in a controlled manner, and from there rover will come out and move around the moon, do some in situ observations, and then beam the data back to Earth. So the work is in progress on that. Just a couple of days back, we did the test of this particular lander, and then satisfied that we are able to build the launcher capability to do such an activity. Work is going on full stream on that. Similarly, you are aware with respect to the Mars mission, in 2013, November 5th, when we launched our Mars orbiter, what the job that was required, if you have to visualize, on that day, the satellite which was released from our PSLV satellite, after traveling for about 10 months, a distance of 600 million kilometers or 60 crore kilometers, on the 24th of September 2014, morning 7:30 a.m., you imagine a cube of 50 kilometers at a particular location in space. After traveling for 10 months and 600 million kilometers, satellite had to be inside that cube if we had to be successful. And many forces, many events could have deviated the trajectory of this particular satellite. Even the sunlight falling on the satellite itself can produce enough force over a period of time and deviate this satellite from its trajectory. And to the credit of the scientists and engineers of ISRO, they were able to conceive, design, and develop a system which worked for such long periods. And also, you can imagine the kind of difficulty that is there. Many times when you turn on your computer, while it takes a few seconds to boot, you feel restless, that you feel why it is so slow. Now, when you give a command to the satellite, Mars orbiter mission, Even at the speed of light, which is 3 lakh kilometer per second, it takes 15 minutes to reach the satellite and another 15 minutes for it to come back. So once you give a command to know that something has happened, it takes half an hour. So you can imagine the plight of the operator sitting at the console, how they should be feeling. So they'll be feeling really restless. So it's been possible for us to show to the world that a mission like a planetary mission can be done in a very different way than what the rest of the world had done. And there we had also demonstrated that it is possible to learn from others' mistake, because Mars mission was considered as one of the very difficult missions. Only 40% success rate was there up to that point of time. And we were the first in our maiden attempt not only to reach Mars but also to go around Mars in our maiden attempt. This was possible because we studied the problems encountered by the failed missions of others and then tried to incorporate some features. Each one of you must have been told that if you make repetitive mistakes, you don't learn from your mistakes, you will be called stupid. But if you are able to learn from others' mistake, then you will be called smart. So definitely the way to go is, whenever you have an opportunity to do an activity, collect as much information as possible, try to study the past, and then learn from that and build a better method of doing things. What this also showed to the country is, in spite of whatever difficulties that may be existing in our country, it is possible to achieve significantly different things which are taken note of by the globe. In fact, on that day, the day we launched our 104 satellites, we put out a video in our website at 11 p.m. in the night. Next day morning, by almost 10 o'clock, more than 1.5 lakh downloads in 104 countries had taken place, looking at how the 104 satellites that was launched was released, because we had carried in that what is called a selfie camera, so that it could tell that each satellite that is released from this launch vehicle can be pictured and then shown that it is actually for real and it is not just for namesake. So we did our Mars mission, and apart from that, we have also done another mission called AstroSat. All of you are, when you look at the sky in the night, you will be fascinated by what happens in the sky. You look at many stars, star constellations. So man has always been fascinated by looking at stars. And while we are on the surface of Earth, and when we look at stars, atmosphere comes in between, and many times clouds can block your view. Even when cloud is not blocking your view, because the signal has to pass through the atmosphere, it gets modified. So if you are able to look at stars outside the Earth's atmosphere, your ability to resolve the finer details and study them becomes better. So we have a satellite called AstroSat, which is in operation since 2 years, and this carries a telescope called Far Ultraviolet Telescope. We can all see through our eyes in a radio electromagnetic spectrum called visible spectrum, 400 nanometers to 700 nanometers. But electromagnetic radiation, you are all aware, extends much larger. Ultraviolet, X-rays, and gamma rays, etc. on one side, radio waves, and then infrared rays on the other side. So you can build instruments to look at these wavelengths and enable our ability to understand things. So what this satellite carries is a far ultraviolet telescope, which has a resolution of what we call angular resolution of 2 arc seconds, which is 3 times better than the next best in the world today. So this particular telescope is actually realized at Indian Institute of Astrophysics with help from ISRO's electro-optical laboratory. And this platform carries a set of telescopes operating from X-ray to far UV, and it can look at change events in the celestial objects. It can study black holes, it can study galaxies, and we are also providing for this satellite opportunity to student community to make a request. We want to study such and such a star at such and such a constellation. The satellite will be pointed to that object, collected data will be provided to the students for studies. So similarly, we have a center in Bangalore called ISSDC, ISRO Satellite, Indian International Space Science Data Center, where all the data collected, whether it is of Chandrayaan or Mars mission or AstroSat, is all available for students to work on. And while we built our capability of launch vehicles, PSLV, I told you already that we have been able to provide a highly credible launch vehicle where not only our satellites but also the satellites of the globe are being launched. We also built a capability to put our satellites into geostationary orbit, and you can imagine that if you have to carry a satellite up to 36,000 kilometers and make it circular there, you require more energy. Typically what happens is, any object which you want to put it in an orbit, you have to carry the object to the required height, and at that height you have to release the object with a predetermined velocity. If you give the right velocity, the satellite will go around the Earth in a circular orbit. If you give higher velocity, the point of release becomes the perigee and the other point becomes apogee, farther away. And if the velocity is less than the critical velocity, it could so happen that the satellite what you release will come and crash on the Earth. So depending on the velocity you give, you can reach different orbits. And obviously, when you want to go to 36,000 kilometers, you require more energy. And for this, we make use of geostationary satellite launch vehicles. And here again, we have succeeded in making cryo-engine development indigenously. 4 consecutively successful missions of GSLV Mark II we did earlier this year, wherein in that launch vehicle, not only did we put a communication satellite into orbit, for the first time in the world, we became a nation which provided to the neighboring countries a communication capability free of cost, and this is a unique example in the world, and United Nations took note of this and appreciated India for providing such a unique feature where, as you are all aware, we believe in Vasudhaiva Kutumbakam. The knowledge you acquire, the capability you learn should not be restricted to only yourself. It should be made useful for the society and the people at large. So India took this initiative. Not only did it provide to our own countrymen, but also the people of our neighboring countries like Nepal, Bangladesh, Sri Lanka, Afghanistan, and Bhutan, and many of these our neighboring countries, this is provided. So this is also a unique example of India's actually friendly behavior with the neighboring countries. And apart from this, today we have a capability of putting up to 4-ton objects into geostationary orbit, and we are continuing to work. One of the things that all of you would have noticed is the things are changing very quickly. The rate of change of technology and the rate of change of things are happening faster and faster. So what it requires is, unless we are able to learn new things, we are able to anticipate some of the developments, our relevance in the world or in the kind of technology area becomes very question mark. So while we build our capacity to put these satellites into orbit, we also need to make sure that we work on advanced technologies and be ready for future. In this area, we have done reusable launch vehicles, which was first attempt last year we did, and we also did an experiment where we could pick up oxygen from the atmosphere and then burnt it along with the hydrogen we carried in the vehicle. So this was another example of, for a future effort, where you don't have to carry oxygen along with your launch, but you can pick up on the way from the atmosphere and go ahead. And similarly, many new areas you need to work on. So what ISRO has been trying to do all along is make use of this technology of space as a tool for addressing specific problems we are facing in the country, whether it is tele-education. Education, for example, in the 2003 time frame, we conceived of a satellite called EduSat, where with 5 spot beams, the entire India was covered, and then remote classrooms, and also telemedicine, where you could link people, patients from remote areas like Andaman and Nicobar to the super specialty hospitals. Via satellite communication, you are able to link. And quickly, of course, terrestrial communication also improved, and there are large number of facilities available today. but still we are coming up with newer capabilities in what are called high throughput satellites, where even remote areas we can provide much larger bandwidth than what we have today. Work is in progress, and all the data that we are collecting, we are also bringing it into a platform called Bhuvan platform. Many of you would be familiar with Google, but if you look at Bhuvan, this platform gives the entire country's information. Almost about 100 different layers of information is available in this. And we also have a portal called Bhuvan School, where school students can actually perform some projects, and based on these projects, they can also understand their neighborhood, and they can understand what is happening in the areas surrounding to them. Recently, in one of the institutions in Karnataka, about 300 students have made use of this Bhuvan platform and then helped us in a program called Space-Based Information System for Decentralized Planning, where the idea is the entire asset of each village is going to be brought into the database, and village elected representatives and sarpanches, they will be trained to understand the information that is available in this platform and help them in planning activities. Some of it could be where to locate the water body, or how to put a series of check dams to recharge the water, and where not to put the waste. So like this, a host of information is possible. So these 300 student groups, what they have done is, they have covered the entire district, and then they have brought in the database of the villages, whether it is school, post office buildings, or hospitals, or whatever facilities that are there in the nearby areas, water bodies, all this, and they are helping not only the process of learning, but they are also helping the country. Similarly, in the recently, one more activity which we did is heritage sites. You are all aware that India has more than 4,000 heritage sites in the country. And the student community project team, consisting of engineering students from civil, mechanical, electrical, and computer sciences, as a team, they go around this heritage site and create what is called a 3D city model. So you can do virtual travel of that place, and this becomes a effective database for the archaeology department and also for the Ministry of Culture. So there is tremendous opportunity for learning through the electronic media that is available, e-portals. We also similarly have a portal in what is called MOSDAC, which tells for next 72 hours, every 3-hour interval, what is the likelihood of rain, what temperature it will be, how much sunlight will be there. So this information also, the student groups and the teachers can make use of this, set up a simple observatory in their lab school, measuring every day what is the maximum temperature, minimum temperature, then correlate their observation with the predicted value for that location, and thereby teach the students methods of statistics, methods of correlation, how it can be useful. So there is a host of opportunity. We'll be more than prepared to work with NCERT. In fact, right now also we have a couple of programs where for NCERT school teachers, we are conducting training programs to tell them about the geospatial features, geospatial technologies, information, and then we can take up this on a much bigger scale. Today, one of the key things is the process of learning, the method of learning becomes extremely important. The earlier methods, what used to be followed, have to be significantly modified. For argument's sake, if you take any mobile today, it has so many sensors that without we having to actually spend money, can make use of this tool and then teach many concepts to the students. In fact, we can even make the students do their project themselves, and they'll be more than happy to do. I'll just give you one example. Using a mobile like this, when a person is traveling on a car or a vehicle, what is the quality of road? That is, it is possible to measure that using this signals that are available from the mobile, using some application tools which are generated by the students themselves. So there is a host of activity. We should make the best use of available tools and then expose the children to the newer capabilities. And another important thing that we need to understand is, since the rate of change is so fast, can we survive with what I learned today for long periods, or should I keep learning new things? If I have to keep learning new things all the time, what should be my method? See, one of the important thing is I should be quickly able to unlearn what I have learned earlier, because if I don't do that, it can become a liability in understanding new things. So this is one of the things which teachers have to really pay attention to. While the methods of learning are taught, the emphasis should be on how this methodology they have comprehended and how quickly they are able to adopt to new methods of new processes and methods. And the task of the teachers today is far more difficult than what it used to be when we learned in our schools, because students have access to data. I'll say data, not information, because many times what the internet gives, it gives all kinds of things. Which is correct, which is not correct is not easily decipherable. But nevertheless, students have some data. They can question their teachers about what they are telling, whether what you are telling is right or not, or ask them questions, uncomfortable questions many times. So the teacher's job is not only to understand what they have learned, keep learning new things, so that the students, when they come and ask questions, they are in a position to answer that. So the challenges are many, answers are not easy to find, but then that is where the teacher's job starts. And then you have been doing a wonderful job so far, and you need to gear up for providing better opportunities to the incoming students, and make them not only understand the learning methods, but we also need to teach them values in life and values in society. Without value, education has no real significance. So it's also important that in today's world, the rich heritage our country has, our country's heritage is thousands of years old. Not everything is bad, not everything is blind belief. So we need to teach our children, you don't have to accept anything of the past just because it is told, but you don't discard it also. You verify, put it through a test. If you are satisfied, accept it. This much at least we should tell our children, because over a period of time, the situation in the country has developed to such an extent that everything that comes from the West is right. What is within local or East is not right. It is not correct. We have a huge heritage. There is a lot of truth in what has been done earlier, but over a period of time, the scientific rigor has been lost. We need to re-question and we need to understand that. So it is the responsibility of all the teachers also to remind our students that we have a rich heritage. While we need not believe everything that is told to us, there is a large amount of truth in what is there. You test it for yourself and accept. So in the end, let me complete my talk on this. In India today, what ISRO has done is, it is possible in the country, if you dedicate yourself, work as a team, a group of people dedicated to a focused task, it is possible to achieve great things in life, where not only it is possible to provide solutions to the problems we face in the country, but also in the process get recognized globally as a team which is doing a significant job. So it is possible if you work as a team. So team spirit is extremely important. Today, any discipline you take, it is not possible to be understanding the entire thing by the knowledge of that discipline alone. It is an interdisciplinary world. So ISRO, if you take, we have people from biology, zoology to chemical engineer or the computer scientists. So you have all kinds of people working, including we have the artists, film artists, and then we have a development and educational communication unit which had the task of actually starting the program software required for reaching out to the villagers. And today also we have this team trying to come up with new methods of communicating to the students. So an interdisciplinary approach is the essential thing of the day, and we need to make students understand that, and it is possible for us if we work together to achieve glory. And I want to take this opportunity to wish each one of the students who are here a great success in their life, a great career ahead, and also reminding them of a responsibility. What our Chief Secretary mentioned, the dividend that we have, if it has to lead India into the #1 country of tomorrow, the so-called Vishwa Guru of the world, it is in your hands. If you make up your mind, we will become a #1 country in the world. Thank you.
Thank you, sir, for your inspiring talk, Development of Scientific Spirit Among Children. You have amply excited all of us about space technology and its immense utility to mankind. Thank you once again, sir.